Okay, so this is the last session number 12, numerical methods to solve ordinary differential equation. Which one is the last method that we finished?
Picard's.
Picard's. Good, very good. So the Picard's method that we seen, which use the integration formulae. Actually, we require integration formulas for Picard's method, but whatever the methods that we'll learn today, nowhere we require any integration formula. Okay, no calculus, no trigonometric identities, nothing we require, just a use of calculator is required there. So the purpose is the same. The purpose is to solve the ordinary differential equation, and the methods are Euler's method. The first method today you will learn is Euler's, then Euler's modified method, and in the syllabus itself it is written it is a one-step method. That's one. Then RK method or Runge-Kutta method. Okay, so that is these are the two different scientists, and they together written that or derive that method. So the name is given as a Runge-Kutta method there. So these are the four methods that we have in our syllabus. Started with the Picard's method, then two methods by Euler. One is a Euler's method and another is a modified method. Obviously, the name suggests modified method is definitely the better than the normal method, which gives us a more accuracy. Okay, and Runge-Kutta method also gives us a good accurate answer there. So all these three methods of the today's session are completely the numerical methods, nowhere calculus required, nowhere integration is required. Okay. So let me start the first method. The first is the Euler's method. Now, the purpose of all these methods we already seen. Our aim is to solve this ODE, that is dy by dx equal to f of xy. So this is the ordinary differential equation of first order and first degree. We want a solution of this ODE at xn. So we want actually the value of y equal to fx at xn, and we are given the initial condition. So this is also known as the initial value problem, that is y of x0 equal to y0. So that is the nature of a problem that we have. Now the formula for Euler's method is for Euler's method, first of all we should decide the number of iteration. Let me assume there are n iteration. Okay, so if we want n iterations, then this initial value is x0 and we want at xn, so we get interval x0 to xn. So this interval x0 to xn will divide into n equal parts. Okay, it's just like they're dividing that interval AB into the n parts, like we divided it in, yes, in which method we're dividing this interval, we get this value of h also. It is similar to the previous method. Yes, previous article. Which article we completed?
Picard's.
Not Picard's. Not Picard's. In Picard's, nowhere we require that h as a class interval because it is just
The interpolation.
not interpolation. Interpolation, yes, we have
Lagrange's.
all different
The
answers, but
Newton Gregory.
no, none of the answer is correct.
Falsy.
Pardon?
Sir, regular falsy method.
अभी जो बची है वो भी बता दो. Okay, so the final answer not correct. This type of the things we are doing actually in numerical integration. Numerical integration, you learn this method. Which methods? Yes.
Simpsons.
The trapezoidal Simpson.
Trapezoidal and Simpsons. There we divide actually this interval into the n parts, and we get h as a class interval. Yes, some of you are said that about interpolation. Yes, interpolation we have similar thing, but it is not like for h is equal to there. So it is like ax plus h is equal to. There is something different. Okay, so don't confuse with the formulas. You should recall the correct things in the correct method there. So that is main thing. So first of all, in Euler's method, in Euler's modified method and RK method, in all the three methods, actually you will have this interval x0 to xn. Okay, but in modified and RK method, the number of iteration, that n is always 1. The number of iteration is always 1. So h is actually directly xn minus x0. H is equal to xn minus x0 in modified and RK method, that is Runge-Kutta method. But only in Euler's method we are getting the value of value of y at xn. Step by step we are reaching to that. So come to the iterations now. Iteration formulas that you should remember. So first iteration is y1. y1 equal to y0 plus h f of x0 y0. So we get, can anyone tell me this value of y1 will be at x equal to x1, obviously, is it? Because
Yes, sir.
yeah, correct. So this x0 to xn, when we take this h, actually due to this h, this interval is divided into n equal parts. So we get n plus 1 points, x0, x1, x2, x3 up to xn. x0 to xn, there are n plus 1 points. And okay, so I'll not go in the detail. So these are the formulas. Just remember the nth iteration formula. This is the general formula. Yn equal to yn minus 1 plus h times f of xn minus 1 yn minus 1. So obviously the nth iteration depends on n minus 1th iteration. Now see the examples. Really it is a formula based, no difficult things are there. So the important task is you have to remember the formulas. That is the main task. See the first example. The question is, using Euler's method, find the approximate value of y corresponding to x equal to 1, given that dy by dx equal to y plus x, such that y equal to 1 when x is a 0. Now first step, all these values we want in a notation. So tell me, what is y equal to 1 represent? In standard
So
notation.
x0, y0.
Yeah, correct. Very good. So this y0 is 1, x0 is a 0, x0 is 0, y0 is 1, and xn is 1. Okay, and we have to solve this. Now, how many iterations we should do? How many iterations should we do here? Is it given in the question?
So 0 to 1
Yeah,
would
yes,
be
yes, we have to go from 0 to 1, but how many, this interval we should divide into how many parts? Is that given?
No, sir,
No,
it's given.
no,
It's
sir.
not given. Okay, so whenever it is not given, choice is our. Choice is our. 99% of the case in the exam, this n is given. The reason is only because there should be a uniform answers, and while correcting, that examiner should have the answers with him. Okay, so because of that, n is always given. But if it is not given, you can take your own. But whenever it is Euler's method, so minimum n should be 5. Okay, so here I take an n equal to 10. So if n is a 10, can you tell me what is the value of h? If n is a
Sir?
10, if n is a 10, what should be h?
So 0.1.
0.1.
Excuse me, sir.
Correct.
0.1.
Yes.
Sir, if n's value is different, would the answer be different?
Yes, obviously the answers are different, but they are approximate answers. They are near to the same, but they are different, not exactly same. Got it?
Okay, sir.
Okay, so because these are numerical methods never gives us an exact answer, and when there is a small change in the iterations also, your answers will differ, but they will not totally different, that one is getting the answer as a 1, a final answer is 1, and other is getting 1000. That is not possible, obviously. So if someone getting 1.2 and other may get 1.23 or 1.3 also, okay, that way. So that possible, but okay, so come to the point. So yes, we have h is equal to xn minus x0, that is 1 minus 0 upon 10, so that will become 0.1. So that is step 1. So step 1, in a solution, let n is a 10, so we divide this interval 0 to 1 into 10 parts, so h is a 0.1. To get h, actually we taken 1 minus 0 upon 10. 1 minus 0 upon 10, that is a 0.1. Now, what is the value of x1? Yes, what is the value of x1? See, this is x0. x0 is a 0. x1 is x0 plus h. It is a 0.1 itself. Na? x2,
Yes,
x2
sir.
is a 0.2, and x10 will be 1. So we get a y. We want actually y10. y10 will be the value of y at x equal to x10, and that x10 is 1 there. I hope you are getting what I'm saying.
Yes, sir.
So the first formula. What is the formula for y1?
So y0
Y0
plus
plus
h,
Okay,
f0,
correct.
x0, y
So y0 is, what is y? y0 is 1.
1.
1. Okay, y0 is 1. So what is f of x0, y0? First tell me what is f of xy?
Sir, y plus x.
1.
Yes, y plus x is f of xy. So what is the value of f of x0, y0?
So 1.
1, correct, because it is 1 plus 0. So that way you will get the iterations now. See here, y1 is y0 plus h of x0 y0. Y0 is itself 1. 1 plus h is a 0.1, and f of x0 y0, if you observe, that is 1. So 1 plus 0.1 into 1, so it is 1.1. I hope you are getting. So we got the value of y1. So this y1 is nothing but the value of y at x1. This is the value of y. 1.1 is the value of y at 0.1. So that way. Similarly, we get for y2. Y2 is y1 plus h times f of x1 y1 now. So to calculate this y2, we should calculate first f of x1 y1. So here is x1 and here is y1. So this should be replaced here. So this is
1.2.
1.2, correct. So this is a 1.2 into 0.1.
Sir,
Yes.
sir, could you please explain that how 0.1 came? H is equal to 0.1.
Obviously, the formula. What is the formula for getting h? Yes, tell me. What's the formula? This is the formula we used in, already I said, numerical integration also. H is equal to xn minus x0 upon n. So how much n we taken here? 10. What it? We assumed n as a 10. So this is the assumption right now because it is not given. You can take n as 5 also. What is xn? Xn is 1. This is xn. This is x0. So it is 1 minus 0. So are you getting it? It is 0.1.
Yes, sir. Yes, sir.
So this is the way we get. So once you get this one, already I said this is f of xy. F of xy is y plus x. So when you calculate this f of x0 y0, f of x0 y0 is y0 plus x0. Y0 plus x0 is 0. Sorry, 1 plus 1 plus 0 there. So, okay, so it is a 1 plus 0. So that is coming 1. That way, and h is a 0.1, so this way you get 1.1. Similarly, f of x1 y1, f of x1 y1 is, you already observed, that is a 0.1 plus 1.1, so 1.1 plus 0.1, that is 1.2. That way, so these values just you have to replace and do a calculation on calculator. Similarly, you have to calculate y3, y4, y5, y6, y7, y8, y9, and y10. It is a lengthy but not difficult. I will say. So it is a 3.18. 3.18 is a value of y at x equal to
10.
x10.
1, 1.
That is 1. Correct. Very good. So, and that's a required answer we want. Actually, we want the value of that y at x equal to 1. And so the final answer you will have is like this. Thus, the approximate value of y is a 3.18. You can say after 10th approximation. After 10th approximation. Is it clear? So this way you have to complete
Yes,
the
sir.
question. Okay. Good. Anyone have a doubt here? See, middle
No, sir.
parts, these middle steps I dropped. This I not calculated in detail. You can do in detail, like write a formula first. What is the formula for y3? What should be the formula?
Y2 plus H f of
y2
x2
plus
y2.
Very good. Y2 plus h times f of x2 y2. That way. Very good. So that's way only. Okay. One more example on Euler's method. So the question is now. The question is use Euler's method, or given dy by dx is y minus x upon y plus x with initial condition y equal to 1 at x equal to 0. Find y for x equal to 0.1 by Euler's method. So just we want at 0.1. Now what should be n? Again not given. Is it?
0.01.
5.
5.
Yeah, okay. N equal to 5 you are going to take it, but it is not given in the question anywhere. So you can take n equal to 10 also. I'm not saying that n should be 5 only. See, which interval we have now? Which interval we have to divide?
So from
0 to 0.1.
Yes, 0 to 0.1. So this is x0. x0 is a 0. xn is a 0.1 and y0 is 1. And this is f of xy. F of xy is y minus x upon y plus x. Okay, so that are the things we have. So the question is very straightforward. I take an n equal to 5. So if I take n equal to 5 and we divide this interval, 0.1 minus 0 upon 5 gives you the 0.02. Check. You can check it. Okay.
Yes, sir.
And just then iterations. So y1 is y0 plus h f of x0 y0. Can you tell me what is the value of x1 here?
0.02,
Correct.
0.
X1 is 0.02. What about x2?
0.04,
Correct. X3, 0.06.
0.06,
Correct. X4, 0.08. And
Point.
lastly, x5. What is x5?
0.1.
Correct. 0.1, which is required. Because that y5 is nothing but it is the value of y at x5, and that is a 0.1. And we should write approximate value of y at that point is this one. So main thing is this n. If it is not given, choice is your. But 99%, again I will tell you, 99% of the case in the final exam, n is always given. Obviously, the purpose is everyone should have the same answer. Otherwise, everyone have the little different answer, and the examiner may not know what is the correct answer there. Okay, so that's the reason only n is given there. But by chance, if it is not given, take it your choice. So minimum n you should take it as 5 because it is Euler's method. It is just simple calculation. You have to do it on calculator. So you don't take n equal to 1 or 2 only. Okay, 1 or 2 is a very small iterations for Euler's. Any doubt in Euler's method? That is the end of first method here. Euler's method.
No, sir.
No doubt?
No, sir.
So let I show you
No,
the
sir,
second.
no doubt.
Okay, good. So the next method is Euler's modified method. This is a one-step method. One-step method means the number of iterations will be only one. So n is always 1 here. See, this is not compulsory one-step method. Actually, you can solve this by n step also. Okay, that n can be anything. But in syllabus, if you see the course handout or syllabus of IMU, there is particularly written it is one-step method only. So in the exam, you will get only one-step method questions there. So again, the task is the same. We are solving this ODE of this type. So one step means n will be 1. If n is 1, so h become xn minus x0. Upon n is 1, divided by 1 is there, not required. So h, that class interval become directly xn minus x0 there. Now, we already know the Euler's method gives us this first approximation. The first approximation is y1 equal to y0 plus h f of x0 y0. So as it is a one-step method, we got the answer here only. Y1 only gives us the answer in modified, but this Y1 will not take as it is as a final answer. So instead of taking that as a final answer, we are going to make it more accurate by more number of iterations to Y1 only. So Y11 is just a formula of a Euler's method. You'll observe Y11 is a Y0 plus h times f of x0 y0. So instead of keeping this as answer, we take y12. Y12 is the second approximation of a y1, and that is done by y0 plus h by 2. Actually, we are averaging the value, functional value between x0 y0 and x1 y11. Here is the change only. This term is always coming. So it is just if you average, f of x0 y0 is replaced by the average of f of x0 y0 and f of x1 y11, then we get y12. And now the similar thing, this y11 is replaced by y12 only, and so on. Now generally this iteration we have to continue till the 4 decimal accuracy. Okay, so I'm generally expecting that you should do this calculation till the 4 decimals start repeating. Okay, once this 4 decimals start repeating, you can stop the iterations for y1 itself. Got it?
Yes, sir.
Okay,
Yes.
I will show you the example, then become more clear. So here is the same question now. This same question we done by Picard's, we done by Euler's. Now we are doing by modified method. But in modified method, this point is changed because h should not be so large. If h is a very large, then the accuracy in the method is not there. So because of that, the question framed like this only. Using Euler's modified method, find approximate value of y corresponding to x equal to 0.1. Actually, in Picard's and Euler's method, we calculated at x equal to 1 there. But now we are calculating at 0.1 only. Given that dy by dx is y plus x such that so all the remaining things are similar. So I want first, as it is a modified method, remember as it is a modified method, Euler's modified method, we should take n equal to 1. Okay,
1.
so n is 1. So what should be h?
Point 1.
0.1 itself, because h is
0.1.
yes, h is xn minus x0, which is 0.1 minus 0, that is 0.1. So step number 1, we should take h is xn minus x0, which is 0.1, and now we'll start the iteration. We'll take y11 first. Okay, so y11 is a y0 plus h f of x0 y0 in the same way, because f of xy is y plus x, y0 is 1, x0 is a 0, so you can replace, and this y11 is the same as y1 of Euler's. In Euler's and Euler's modified method, y11 is the same, but now in Euler's method, from y1 we calculate directly y2, but in modified method we'll not go to the y2. Actually, we are going to make iterations for y1 itself. So this y11 is converted to the y12, and it is averaged here. So if anyone have a doubt for this step, you can tell me. I will show the calculation.
Yes, sir. Can you please show?
Yeah, okay. So I will what calculation you have to do it. Actually, these calculations you have to do on calculator. So first you write a formula. Once you write a formula, you have to replace the values. What is the y0 first? Tell me.
1.
1.
1.
Okay, here is y0. This is given. So 1 plus h. H is a 0.1 there.
Point 1 upon.
Then square bracket f of x0 y0. Now, f of x0 y0 means y plus x. Actually, you
1.
are calculated here also. Okay, that also you can write it directly. So f of x0 y0 is y0 plus x0, and here is y0 is 1, x0 is a 0, so it is a 1 plus 0. So this is f of x0 y0 plus f of x1 y11. Now what is x1 first?
Point 1.
0.1.
0.1.
Correct.
0.1.
Correct. 0.1, because x1 is equal to x0 plus h, and x0 is a 0, h is a 0.1, so it is a 0.1. So x1 is a 0.1. So, and what is the y11? Y
The last
1.10.
iteration.
1.1.
1.1 is y11, and x0 is a 0.1, and that's one. Now, if you do this calculation on calculator, that is 1 plus 1.2. Actually, I think 1 plus 1.2 is it is a 2.2. 2.2 divided by 2. This 2 you have to do it. This 2 actually. So this you will get 1.11. Is it clear?
Yes.
Okay. So that way you have to proceed every time. Now you'll do the calculation for y13 also. This is f of x0 y0 you have to calculate. F of x1 y12 you have to calculate. Replace that, and then you will get this value. And you will start in third and fourth iteration. What important thing happened?
So the numbers are repeating.
Yes, yes.
So
All
the
the four
four decimal
decimals start
places are
repeating.
repeating.
So whenever all the four decimals start repeating, we can say we stop the iteration, and we can say the approximate value of y1 is 1.1105 after this fourth iteration. Okay. Any doubt, anyone?
No, sir.
No. So
No, sir. No
this
doubt.
is a Euler's modified method. So that about Euler's modified. So here is one more question, but this question I intentionally kept here. The reason is only in our syllabus there is one step method. By chance, if two-step question comes by mistake, okay, then for that I am showing you. Actually, you'll observe we have to use a modified method. So modified method means we should have only one step, but here it is 0.2 and 0.4. Two values we have to calculate. That means this is here is x0 y0. So x0 is 0,
0.
y0
0.
0, and x1 is now this one we should calculate at 0.2, na? So it is 0.2. So h is x1 minus x0 or xn minus x0. You can take this as xn also. So if you take x1 minus x0, you get a 0.2. 0.2 as h. H is a 0.2. And now we'll start that method. Say this is y plus e raised to x. That is a function. So that is y1 equal to y0 plus h times f of x0 y0. This is the first iteration, but it is y11 as it is modified method. So you have to calculate this value there. Okay. Can you get this value? Can you do this calculation your own later on?
Yes, sir.
Okay.
Yes, sir.
So using this, you have to proceed for y12 as y0 plus h by 2 f of x0 y0. We already seen these. plus f of x1 y11, that's one, and you'll get y12 also, and so on. And suppose last 4 decimals start repeating, and then you'll get some answer, say y equal to 0.3432, something like that. I'm just giving you, this is not the answer. Okay, this is not the answer. Suppose this is the value of y you will get after certain 3 or 4 iteration at x equal to 0.2. Okay, so this is the end of the first step. Okay, but as we have one more value we have to find out, we will start second step. Now for second step you can take
Excuse
this
me,
as,
sir.
yes.
So could you explain the first step again?
Step 1, just like the last example only. The last example is first step
All
only,
right.
na?
All right, sir. All right.
Okay, so that things only you have to do it. I will show you that this one. This is actually the step 1. Suppose this question is itself asked for 2 steps there. Suppose, okay. So this is the answer. This is the answer you got after step 1. Suppose we have to calculate now value of y. What is y? What is the value of y at x equal to 0.2? If this is a question. If this is a question. Now what we'll do it? We'll take this as x0. We'll take this as x0 and this will as a y0. And again we'll continue with this formula. And see, x0 is 0.1 and x1 will be the point. X0 is 0.1 and x1 will be the 0.2 there. Got it? For the step 2,
Yes, sir.
for step 2, x0 is 0.1, y0 is 1.1105, and this x1 now is a 0.2. And you have to continue this step, and at the end you will get say some y15 or y14, and that is approximate value, approximate value of that y at x1, and that is 0.2 then. So you get one more answer there for 0.2. I hope you are getting. Is it clear?
Yes, sir.
Okay, good.
Yes, sir.
I will show you the answers only here. What I done here. Here just I written the iterations. So this is y1, y11, y12, y13, y14, y15. So this is the step 1. You get 0.2468. That start repeating. And after that, using this value where x x is a 0.2, that is x0 is 0.2 and x1 is this one. Again for 0.4 iteration can be done and you will get this iteration. So 1, 2, 3, 4. But this type of question will not come in the exam. Should not come. Okay, I should say this type of question should not come in the exam. The reason is in the syllabus itself, it is a written one-step method. So this is actually 2 steps. You can take 5 steps also. Suppose we have to find out 0.2, 0.4, 0.6, 0.8 and 1. Suppose at these values you have to calculate. So at each iteration you have to do the inner iterations there. Got it? But
Yes, sir.
that type of question obviously not possible. They never come. Maximum 2 step, but that should also not come. The reason is because of a syllabus. Okay, come to the last method now. These are the answers here. Y of 0.2 is 0.2468 and y of 0.4 is 0.6031 approximately in 2 steps there. Okay, that's one. So the last method is a RK method, Runge-Kutta method. Again, it is a one-step method. Here is only the formula difference is there. So n is 1, h is xn minus x0. All the similar things are there, and the formulas are here. So this is the different formula. So here we always get the value of y at x1 by y0 plus k only, and k is calculated with this formula 1 by 6. Actually it is a averaging of these k values. So, and there are few weightages given for k2 and k3 as a double weightage, and so that is a method. It is based on the method. We will not go in the derivation of a formula. So the formula is a k1 plus 2k2 plus 2k3 plus k4 divided by 6. So k1 is calculated with this formula. K1 is h times f of x0 y0. K2 is h times f of x0 plus h by 2 plus y0 plus k1 by 2. K3 and k4. So again, the formulae, the bigger task to you, I will tell you that the most important task for you to remember these formulas. And how to remember? Obviously, when you practice 2-3 questions on paper, when you write these formulas on paper, okay, automatically you will remember this formula. Not so difficult to by heart. Okay, but if wrong small error is in the formula, obviously if you use wrong input, your output is also wrong. You will get wrong answer and you will lose your marks. So you should take a caution while writing formulas. You should very alert. Okay, you should be alert while writing the formulas there. Don't make a silly mistakes in formula itself.
So for this, it will be till K4 only every
Yes,
time.
yes, always K4. No, this is actually K1, K2, K3, K4, and yes, that is only there in the formula, and that we use in Y1. So it is not like again and again iteration, nothing like that. So
Okay, sir.
directly it gives us in one step that value of Y1 there. Okay, so let I show you. So same question again, RK method to solve at for point 2 now, and y plus x is there, and these are initial condition. Okay. So this is known as RK method of a fourth order that is in our syllabus. So see the solution. First x0 is a 0, y0 is 1, h is a 0.2, and f of x0, y0 is 1 there. Okay. I hope you can see that all that things in from the question. So h1.
Yes, sir.
First we'll calculate k1, k2, k3, k4. K1 is h times f of x0, y0. You'll observe. So h is a 0.2. 0.2 into that you will get k1. You calculate k2. Can you tell me what is x0 plus h by 2? This x0 plus h by 2 value?
0.2.
0.1.
0.1.
0.1, correct. So here is f of 0.1, and then this is y0 plus k1 by 2. This k1 by 2 you have to do that, and you will observe it is 0.1 and 1.1 there. So this is a x0 plus h by 2 is a 0.1. X0 plus h by 2 is a 0.1. So this is a x0 plus h by 2, and this is a y0 plus k1 by 2 value. Okay, y0 is there, k1 is there. So everything you can do that and use this formula here then to get f of x0 y0. Sorry, this f of this value is 0.1 plus 1.1. That is 1 point. Then you get all these values. Is there any doubt in calculating k1 to k4?
No, sir.
Okay, good. So just remember the middle values are h by 2, h by 2, k1 by 2, k1 by 2, and there is a twice in the formula that later on in the formula these k2 and k3 given double weightage there. 2k2 and 2k3 is there, and in between here is h by 2 and k1 by 2 is there. But first and last are direct there. Okay, that way. So you should remember this formula. So then k is calculated. Once you get k, what should the last thing? Y1 is equal to y0 plus k. That is the last formula. So y1 equal to y0 plus k, and this is the final answer. 1.2468 is the value of y at point 2 of the solution of that differential equation approximately. Got it?
Yes, sir.
Yes,
So
sir.
this way you should follow. First, write the given things in notation, calculate k1 to k4, then calculate k, and lastly write y equal to y0 plus k. That way. So one similar question I shown it here, but this time f of xy is a little complicated. But don't worry, you have a calculator with you. You should be able to calculate that f of x0 y0, which is y0 square minus x0 square divided by y0 square plus x0 square. So you cannot give any excuse for this lengthy calculation. You should practice. Don't do the silly mistakes in calculation. The topic is a very simple but little calculative. Okay, little calculative, and you can easily get the marks in this topic there. That about our last method, RK method. Okay, so we completed the four methods actually, four methods to solve ODE. Started with the Picard's, Euler's modified, and RK. Today's three methods are completely numerical method, no calculus you observed, only simple algebra and the calculations you have to do it. Okay, and if I sum up our entire unit now, first chapter that we completed, the first chapter that we completed is numerical method, and in numerical method we have four main articles: solving algebraic and transcendental equation, where we learned three methods, Then we have second part as interpolation. For interpolation, actually we learned finite differences first, and then we use three methods again: forward, backward, and Lagrange's. After that, we have numerical integration. In numerical integration, again, I think we have three methods. These are Simpson's 1/3 and 3/8 and trapezoidal. And lastly, we have this solution to the ODE where we learned four methods. So that about our syllabus. Okay.